term neutral has been defined in the National Electrical Code. According to the National Electrical Code 2011, neutral is a conductor connected to the system neutral point or derived from the neutral point through a transformer or other source. The National Electrical Code 2014 and later defines neutral as a conductor connected to the neutral point of the system derived from the neutral point through a transformer or other source, or designated as a neutral. The term neutral is often used in electrical systems to refer to a conductor that has an approximately 0 volts potential with respect to the system ground. This conductor is typically the center point of a three-phase system or the midpoint of a single-phase transformer secondary. The term neutral is not synonymous with grounded. A neutral conductor may or may not be grounded depending on the system configuration. In grounded systems, the neutral conductor is intentionally connected to earth ground for safety and stability reasons. However, in ungrounded systems, the neutral conductor is not connected to earth ground. While it is true that the neutral conductor is often grounded, it is not always the case. For example, in an ungrounded system, the neutral conductor is not grounded. Therefore, using the term grounded to replace neutral would not be accurate in all cases. Furthermore, the term neutral has a specific meaning in electrical systems and is commonly used by industry professionals. Changing the terminology could lead to confusion and misinterpretation. In conclusion, the term neutral has been defined in the National Electrical Code and should not be replaced with the term grounded. While the neutral conductor is often grounded, it is not always the case, and the term neutral has a specific meaning in electrical systems. The neutral conductor plays a vital role in alternating current, or AC, power distribution systems. It serves as the return path for current from the load back to the source, typically a transformer. The neutral conductor is usually connected to ground at the service entrance, establishing a common reference point of 0 volts potential. This grounding provides a safety measure, limiting voltage on the enclosures of electrical equipment and diverting fault current in the event of a short circuit. The neutral conductor is essential for proper operation of single-phase 120 volts and 240 volt circuits, as well as three-phase Y-connected systems. In a balanced three-phase system, the neutral conductor ideally carries very little current. However, in unbalanced conditions, where the loads on each phase are not equal, the neutral conductor carries the imbalanced current, ensuring that all loads receive the correct voltage. The size of the neutral conductor is determined by the expected maximum imbalance current. The National Electrical Code provides specific guidelines for neutral conductor sizing based on the type of load and the system configuration. The neutral conductor must be properly insulated and protected from physical damage. It should be identified by a white or grey-colored insulation to distinguish it from the phase conductors. Proper termination and bonding of the neutral conductor are crucial for maintaining a safe and reliable electrical system. The neutral conductor should be connected to the grounding electrode system at the service entrance, providing a low impedance path for fault current to return to the source. The neutral conductor also plays a key role in reducing electromagnetic interference, or EMI, in electrical systems. By providing a low impedance return path for current, the neutral conductor helps to minimize the loop area of the circuit, reducing the amount of radiated electromagnetic energy. The neutral conductor is also used in some types of surge protection devices, or SPDs, to provide a path for surge current to ground, protecting sensitive electronic equipment from voltage spikes. The National Electrical Code contains detailed requirements for the installation and wiring of neutral conductors, covering topics such as conductor sizing, insulation, identification, termination, and bonding. Compliance with these requirements is essential for ensuring the safety and reliability of electrical systems. The NEC also addresses specific situations where the neutral conductor may be intentionally switched or interrupted, such as in some types of motor control circuits. These applications require special precautions to prevent dangerous voltage build-up on the disconnected neutral conductor. The neutral conductor is a critical component of modern electrical systems, providing a safe and reliable return path for current and serving as a reference point for voltage. Understanding the function and requirements for neutral conductors is essential for anyone working with electricity. The neutral point, as mentioned in the definition, refers to the common connection point in a multi-phase system, typically a three-phase Y-connected system. In such a system, three conductors each carry an alternating current that is 120 electrical degrees out of phase with the other two. The neutral point is the point where the three phases are equally spaced in voltage and is theoretically at 0 volts potential with respect to each phase. This neutral point can be established within the source, such as a generator or transformer, or it can be derived externally using grounding transformers or impedance grounding devices. The term derived from the neutral point through a transformer or other source indicates that the neutral conductor can be created by connecting to the neutral point of a transformer secondary winding or by using other specialized equipment. For example, a zigzag transformer can be used to create a neutral point in a delta-connected system which inherently does not have a neutral. Or impedance grounding devices, such as neutral grounding resistors, or NGRs, can be used to limit the ground fault current while still providing a reference to ground. The neutral conductor is often grounded to earth at the service entrance of a building or facility. This grounding provides a low impedance path for fault current to return to the source, which helps to trip circuit breakers or fuses quickly, de-energizing the faulted circuits and preventing electrical shock hazards. However, it is important to note that the neutral conductor is not always grounded. In some systems, such as ungrounded delta systems, the neutral conductor is intentionally left ungrounded. This type of system can provide some advantages in terms of service continuity, as a single ground fault will not trip a circuit breaker. However, ungrounded systems can also be more difficult to troubleshoot and can be subject to transient overvoltages. The term designated as a neutral, which appears in the National Electrical Code 2014 and later versions, indicates that a conductor can be intentionally identified and used as a neutral conductor, even if it is not directly connected to the neutral point of the system. This is sometimes done in existing installations where it is necessary to add a neutral conductor for new equipment or loads. The designated neutral conductor must meet all of the requirements of the National Electrical Code for neutral conductors, including proper sizing, insulation, and identification. It is important to distinguish between the neutral conductor and the grounding conductor. The neutral conductor carries current under normal operating conditions, while the grounding conductor only carries current during a fault condition. The grounding conductor provides a path for fault current to return to the source, which helps to protect people from electrical shock hazards. The neutral conductor is typically insulated with white or grey-colored insulation, while the grounding conductor is typically bare or insulated with green-colored insulation. The National Electrical Code contains detailed requirements for the installation and wiring of neutral conductors and grounding conductors. Compliance with these requirements is essential for ensuring the safety and reliability of electrical systems. The NEC also addresses specific situations where the neutral conductor and grounding conductor may be combined, such as in some types of equipment grounding conductors. These applications require special precautions to prevent objectionable current from flowing on the grounding conductor. The neutral conductor plays a critical role in modern electrical systems, providing a safe and reliable return path for current and serving as a reference point for voltage. Understanding the function and requirements for neutral conductors is essential for anyone working with electricity. The concept of a neutral conductor is closely related to the concept of balanced and unbalanced loads in three-phase systems. In a balanced three-phase system, the loads on each of the three phases are equal, and the current flowing in each phase is the same. In this case, the neutral conductor carries very little current, as the currents in the three phases cancel each other out. However, in an unbalanced three-phase system, the loads on each of the three phases are not equal, and the current flowing in each phase is different. In this case, the neutral conductor carries the imbalanced current, which is the difference between the currents in the three phases. The size of the neutral conductor must be sufficient to carry the maximum expected imbalanced current. The National Electrical Code provides specific guidelines for neutral conductor sizing based on the type of load and the system configuration. For example, for household ranges and electric clothes dryers, the neutral conductor can be sized smaller than the phase conductors, as the expected imbalanced current is relatively low. However, For other types of loads, such as nonlinear loads that generate harmonic currents, the neutral conductor may need to be sized larger than the phase conductors to accommodate the harmonic currents. Harmonic currents are currents that have frequencies that are multiples of the fundamental frequency, which is typically 60 Hz in the United States. These harmonic currents can cause overheating of the neutral conductor and other electrical equipment. The National Electrical Code requires that the neutral conductor be sized to carry the maximum expected harmonic current. The neutral conductor is also important for voltage regulation in electrical systems. Voltage regulation is the ability of the system to maintain a constant voltage level under varying load conditions. If the neutral conductor is undersized or poorly connected, it can cause voltage drop, which can affect the performance of electrical equipment. The National Electrical Code requires that the neutral conductor be properly sized and connected to minimize voltage drop. The neutral conductor is also used in some types of ground fault protection systems. Ground fault protection is a type of protection that detects ground faults, which are faults that occur when current flows from a phase conductor to ground. Ground fault protection systems typically use a current transformer to monitor the current flowing in the neutral conductor. If the current in the neutral conductor exceeds a certain threshold, the ground fault protection system will trip a circuit breaker, de-energizing the faulted circuit. Ground fault protection is required by the National Electrical Code in many types of electrical systems, including services, feeders, and branch circuits. The neutral conductor is a critical component of modern electrical systems, providing a safe and reliable return path for current and serving as a reference point for voltage. Understanding the function and requirements for neutral conductors is essential for anyone working with electricity. In summary, the neutral conductor serves several key functions in electrical systems. Firstly, it provides a return path for current from the load back to the source, completing the electrical circuit. Secondly, it establishes a reference point of 0 volts potential, which is essential for the proper operation of many electrical devices and equipment. Thirdly, it helps to maintain voltage regulation by minimizing voltage drop. Fourthly, it can be used in ground fault protection systems to detect and interrupt ground faults. Fifthly, it plays a role in reducing electromagnetic interference by providing a low impedance return path for current. The National Electrical Code contains detailed requirements for the installation and wiring of neutral conductors, covering topics such as conductor sizing, insulation, identification, termination, and bonding. Compliance with these requirements is essential for ensuring the safety and reliability of electrical systems. The neutral conductor is a vital part of the electrical infrastructure, and its proper functioning is essential for the safe and efficient delivery of electrical power. It is important for electricians, engineers, and other electrical professionals to have a thorough understanding of the principles and practices related to neutral conductors. The National Electrical Code is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date on the latest requirements for neutral conductors and other electrical equipment. There are many resources available to help electrical professionals stay informed, including the National Electrical Code itself, as well as training courses, seminars, and publications. By continuing to learn and improve their knowledge of electrical systems, electrical professionals can help to ensure the safety and reliability of the electrical infrastructure. The information provided here is for general educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or engineer before working on electrical systems. Working with electricity can be dangerous, and it is important to take all necessary safety precautions. Wear appropriate personal protective equipment, such as gloves and safety glasses, and always to energize circuits before working on them. The neutral conductor is an essential component of electrical systems, and its proper functioning is critical for safety and reliability. By understanding the principles and practices related to neutral conductors, electrical professionals can help to ensure the safe and efficient delivery of electrical power. The neutral conductor is a foundational element in electrical engineering, ensuring balanced operation and safety in power distribution networks.